Okay, we got an exam coming up shortly. I've broken the review up into 4 parts. This is part 1, covering equations and inequalities. So feel free to skip ahead to any part of the video that you want. Just to preface this, I will say that I started off simple and I progressively built on that when I was making this review. So it eventually gets harder and harder as you go. That was kind of my intention. Because you're not going to see the easiest questions. You might not see the hardest questions, but you do need to know how to do the math. So I'll give you a wide variety so you can get anything that's thrown at you. Okay. So I'm going to zoom in here. We're going to do number 1. So we're just solving this equation. Now, I think for the most part, we should really all know how to solve this equation. I'm going to use a different color this time. Let's use blue. I think it's a nice color. We're going to go with the middle shade of blue. All right. So solving for x. So what we're going to do, we're going to try and cancel the 12 out and the 4 out. Cancel those things out, and then we'll have x equals whatever number, right? So we're going to start by subtracting 12. 12 minus 12 cancels out, makes that 0, and leaves us with 4x on the left-hand side. Now, don't forget, though, I have to subtract 12 on the right-hand side as well to keep both sides balanced. So 20 minus 12, I can subtract that together and end up with 8. I divide by 4 now to get rid of this 4. And I end up, don't forget to do it with the other side. I end up with x equal to 2 as a result. All right, moving right along. Number 2. Number 2, very similar, right? So in this case, we're going to have to add this 21 to get rid of this 21. The opposite of minus 21 is by adding it, right? So that'll cancel out. We'll have negative 3x equal to 108 plus 21, which is 129, and then we need to divide by a negative 3. And this comes out to, let me use my calculator real quick. 129. Okay, negative 43 is the answer there. Okay, now we have variables on both sides. So maybe you fast forward to this part of the video because you figure out how to do this. So essentially, we want to get these x terms together, and we want to get the constant terms together as well. So I always try to move the x term first. I want to try and get these two terms together. So I usually take the smaller one and we'll move to the other side. So this 4x, let's try to cancel it out from here and then move it over to this side instead. Now to do that, I would have to subtract 4x. Because 4x minus 4x will have it disappear from this side. And when I do it to this side, the right-hand side, I can combine these together. So that leaves me the equation 15 equal to 19 plus 2x, because 6x minus 4x combines and makes 2x. So now I'm solving for x, just like numbers 1 and number 2. Now, I don't want to move the 15 over. I saw a lot of people making that mistake, moving the 15 over. That's a bad idea because the x term is on this side, right? So why would we want to add more things to this side? We want to get rid of things from this side, right? So let's start by moving the 19. We can get rid of that. So we'll subtract 19, and now we have one less thing on the side with the x. That's going to be 2x equal to negative 4, and then divide by 2, and finally we end up with x equal to negative 2 as a result. Number 5, we're going to start by, well, you don't actually have to. There's more ways than one here of solving it, but I'll distribute. I think that's what most people do. So 5 times 3x, it turns into 15x. And don't forget to do 5 times negative 2 as well. 5 times negative 2 turns into negative 10 equals to 35. So we just combined or distributed. And now we're just solving, again, a regular equation for x. So we will add 10 to cancel that 10 out. And make sure we add it to the other side as well. So this ends up being 15x equal to 45. Now we'll divide by 15. And we get a simple answer that is x equal to 3. 45 divided by 15 turns out to be 3. Now, number 5. Okay, so a few things to do here. Now, avoid this mistake. Do not do 14 plus 2. Do not make this 16. That is a bad idea. Reason being is it breaks the order of operations. Order of operations, you have to multiply before you add. So you're technically multiplying this 2 times x minus 5. So you have to multiply these together before you add any terms. So that means distributing in this case. Leave the 14 alone. We can't do anything about it now. Distribute 2x, and 2 times negative 5 turns into negative 10. Okay, so you know that 2 times x minus 5 turns into 2x minus 10 equals 24, still here. Now that I've done that distributing, now I can go ahead and combine this 14, not with the 2, but with the 10. 14 minus 10 is 4. I'll bring this 2x down for now, plus 2x equals 24. Again, a regular equation to solve. So subtract 4 to cancel that out. Ends up with 2x equal to 20. And then when, of course, you divide by 2, we end up with x equal to 10 as our answer. Now, number 6 is a work of art. It's a long problem, but it embodies or encompasses everything that we've done through the first 5 questions. Distributing, combining like terms, variables on both sides, all those things. So if you can distribute, if you can combine like terms, if you can solve variables on both sides, then you can do number 6. Okay, just a handful. We'll start by distributing. Remember, anytime you see this multiplication, you've got to take care of this multiplication. We're going to distribute these 2 pieces here. So we're going to start with the 3. Let me remove this line if you don't mind. I'm just going to leave in some space. I'm going to distribute the 3 times the 2x and the 3 times 7. So that gives me 6x. Remember, you multiply when you distribute, plus 21. I'll bring this minus 10 down. I'll bring this 15 down as well. Remember, do not add those together because you have to do the multiplication here first. So 4 times x is going to be 4x, and 4 times 1 turns into 4. So I've converted the multiplication into these groups. Now, let's look for like terms. Now, on the left-hand side, I see these 2 numbers, 21 and 10. I can combine those. So we would have 6x plus 11. 21 minus 10 combined to make 11. And on the right-hand side, I can combine the 15 and the 4. 15 plus 4 makes 19, so that would be 19 plus 4x. So now it's just like number 3, now we just got to combine the x terms and combine the regular constant numbers as well. So just like number 3, I'm going to pick the smaller of the x terms and move that. So that's the 4x. So because it's positive, we'll subtract 4x, try and cancel that out. So we'll subtract 4x here. Now that lets us combine this. This makes 2x. Bring down the 11, bring down the 19. Let's move all this over here. So 2x plus 11 equals 19. And just like a normal equation now, subtract 11. We have 2x equal to 8. Divide by 2. We end up with x equal to 4. A very, very long problem. But if you could do this problem, you can pretty much do any of them. Okay? There's definitely room to make a mistake in there, so be very, very careful about what you do in this problem. Make sure if you work this problem out and you got it wrong, find out what you did wrong, find out where the mistake was, and try to avoid making it again. Okay, number 7. Number 7 is actually a very simple problem because it revolves around the zero product property. I won't talk about the zero product property here or why. We've done this in the past. You can go watch the old notes video about it. I'm just going to work the problem out. So when you have 2 groups being multiplied together that equals 0, then each of these groups has the possibility of equaling 0. So we take both of them and we set them equal to 0. That one equal to 0 and this one equal to 0. So essentially we create 2 equations. X plus 4 gets set equal to 0 on its own, and then the x minus 5 gets set equal to 0 on its own. If you care as to why, just go back, find the old zero product property on my channel, and it'll explain why. But now we just solve these 2 equations. So first one, we would subtract 4, and we'd end up with x equal to negative 4. On the second one, we would add 5 to cancel out the minus 5, and that leaves us x equal to 5. We have the 2 answers of negative 4 and 5. Number 8 is exactly the same problem, just a little bit more math. So take each of these and set them equal to 0. So 2x plus 5 equal to 0, and 3x minus 8 equal to 0. So 2 equations, 2 answers. So subtract 5 on the first one. That's 2x equals negative 5. And then divide by 2. Now, we don't get a perfect number here. We get a fraction, but it's okay. Just leave it as a fraction. X equals negative 5 halves. And let's solve the second one. So we'll get rid of the minus 8 by adding 8. So we'll add 8. We get 3x equal to a positive 8. And then we divide by 3. Again, we get a weird fraction, but there's nothing really wrong with that. It's just 8 divided by 3, or 8/3. All right, that covers the equations. Let's do some of these inequalities. So the inequalities work out the same way as an equation with a few minor inconveniences. Anytime you divide by a negative, you have to remember to flip your sign. That's the main thing. And also, we have to graph on these problems. We didn't have to graph on the equations. So here we're going to solve this problem like a normal equation. We'll subtract 7 to cancel it out, so minus 7. This ends up being 3x greater than or equal to, don't forget, okay, it's an inequality sign. It is not an equal sign. So don't write the equal sign. That's a common mistake. 1 minus 7 is negative 6. So now divide by 3, and we have x greater than or equal to negative 2. Now, that's our answer. Now we need to graph it. So what I like to do is just put negative 2 somewhere in the middle of the graph. So I'll surround it with its neighbors, negative 1, 0, 1, 2, 3, negative 3, negative 4, negative 5, negative 6, negative 7. Now let's graph our shaded line. So we're going to have a closed circle at negative 2. Why is it closed? Because our sign has a line underneath it, right? Like this, less than or equal to, greater than or equal to. Those lines under it means it'll be a closed circle. If it doesn't have a line under it, like regular greater than or regular less than, then it's an open circle. But ours has the line under it, so it's closed. Now this saying x is bigger than negative 2. So bigger numbers than negative 2 are like negative 1, 0, 1, 2, 3. All these numbers are bigger than negative 2. So these numbers in this region is where we will shade. And we'll have a graph, something like that. Now, let's do number 10. So again, solve it like a normal equation, right? We'll add 5, cancel that out. We have negative x less than or equal to. Again, don't forget, it's still an inequality symbol, not an equal sign. 13 plus 5 is 8. Oh, 18, I'm sorry, 18. Now, here's the catch, right? The x isn't by itself. We have to divide by negative 1 because it is a negative 1x. So we have to divide by this negative 1 to get rid of that negative. Now, the funny thing is, because we divided by a negative number, we have to flip our sign around. So now it's going to be x greater than or equal to our answer of negative 18. So 18 divided by negative 1 became negative 18. So we'll put this on the graph. So we'll put negative 18 again somewhere in the middle, and I'll surround it with its neighbors. Negative 17, negative 16, negative 15, negative 14, negative 13, negative 19, negative 20, negative 21, negative 22, negative 23, etc. So same reason as number 9, this will be a closed circle on negative 18, and also same reason as number 9, it's x is bigger than negative 18. So negative 17, negative 16, negative 15, negative 14, all the numbers on the right side are bigger, so we are shading the numbers on the right side. Number 11. Again, solve it like a normal equation. So add 14 to cancel out 14, so plus 14. This gives us 4x greater than 40. Then divide by 4. Now, notice we're not dividing by a negative, right? We divided by a positive 4, so the sign does not flip around. It stays the same way. 40 divided by 4 becomes 10. So we'll graph this. Again, we'll put 10 somewhere in the middle. So 11, 12, 13, 14, 15, 9, 8, 7, 6, 5. All right, so we'll have an open circle on 10, and x is bigger than 10, so 11, 12, 13, 14. Again, all these numbers are bigger than 10, so we will shade that direction. Number 12, again, solve it like a normal equation. So we're going to distribute first. This will become 6x minus 3. Be very, very mindful of your minus 3. Some people are going to forget to put that because you have to do 3 times negative 1. 3 times negative 1 becomes minus 3. Less than or equal to 21. And now, again, continue solving. So add 3 to cancel out the minus 3. We end up with 6x less than or equal to 24. And then divide by 6. So remember, we're dividing by a positive number, So we leave the sign the way it was. It's only if you divide by a negative number when you flip. This becomes 4. X is less than or equal to 4. So we're going to put 4 in the middle. We'll surround it by its neighbors, 5, 6, 7, 8, 9, 3, 2, 1, 0, negative 1. It'll be a closed circle, a filled-in circle at 4. Now, this one's a little different. It's less than 4. So the numbers like 3, 2, 1, these numbers are less than 4. These numbers get shaded in. Number 13. So number 13, solve like a normal equation. I'm going to take the smaller of the x terms and move it first. So since it's positive 2x, I'll subtract 2x to cancel it out. So subtract 2x here, combine those terms. I end up having negative 9 less than 5 minus 2x, which is going to be 3x. Bring down the minus 24. I'm still trying to get the x by itself. So now let's get rid of this 24. Let's add a 24 so I can move it from the side with the x over to the side with the 9. So we're adding 24. This gives me 15 less than 3x, and we'll divide by 3. We end up having 5 less than x. So again, we'll put our 5 in the middle. So we'll put 5, maybe 6, 7, 8, 9, 10, and 4, 3, 2, 1, 0. This is an open circle at 5, and now be very careful of how you read this because it's kind of backwards from how we normally have it. This right here says that x is bigger than the 5, right? So remember, think about it. It's opening up towards x, so the x is a bigger number than 5. So if x is bigger than 5, it could be 6, 7, 8, 9, 10. It could be anything on this side, so we'll shade this side. Number 14, a lot of distributing here, so be very careful with your results. We end up with 3x minus 12 greater than or equal to 10x. Oh, this one's a tough one. Negative 75. So minus 75. We'll combine the x terms. Again, I like to move the smaller of the x terms, so I'll move the 3x. So I'll subtract 3x. This leaves me negative 12 greater than or equal to 7x minus 75. It's very much the same thing as number 13. We'll add 75 here to cancel it out. Add 75. So this is going to be 63 greater than or equal to 7x. So let's move that over. 63 greater than or equal to 7x. So we'll divide by 7. And again, I'm dividing by positive, so the sign does not need to change. We end up having 9 greater than or equal to x. So we'll put 9 in the middle. 9, 10, 11, 12, 13, 14, 8, 7, 6, 5, 4. So this is claiming that x is smaller than 9. So we're going to have a closed circle at 9, and then we're going to shade in the numbers that are smaller. So x is smaller than 9. So 8, 7, 6, 5, all these numbers are smaller than 9. So we're going to shade them in. That's our answer. Now we have to get towards compound inequalities. Compound inequalities are just like the regular inequalities, but it's a 2 for 1. So here we have an and inequality. Remember, there are 2 types. There's and or inequalities. So or inequalities will say or on them. That's how you can tell what they are. Otherwise, it's going to be an and inequality. All right. So when we're solving this, our goal is to get the x by itself. But the problem is there are 3 sides to our inequality. We have a left side, a middle, and a right side. What we want is we want x by itself in the middle. So notice the x is not by itself in the middle. It's got this minus 1. So cancel it out, right? The opposite of minus 1 is plus 1. There we go. We've canceled it out. So now the x will be by itself in the middle. But I have to keep things balanced. So since I added 1 to cancel it out, I have to add the 1 to the other sides as well. So I'm going to add 1 to the left, and I'm going to add 1 to the right. And this results in 3 and 8. Now, there was no division here. There was no dividing of a negative, so the signs will stay exactly the way they were. And there's our results. X is between 3 and 8. So on our number line, we'll have to make sure we have 3 and 8. So we'll have 3, 4, 5, 6, 7, 8, 9, 10, 11. We'll do 2 and 1. So we're going to have a closed circle at 3 because of the sign on the 3. And we also have a closed circle at 8 as well. And x is between 3 and 8, so we shade between these two circles. And we have our final answer right there. Let's try it again. Let's try number 16. So 16, same idea, right? There are 3 sides. You have a left side, a middle, and a right. We want the x to be by itself in the middle. So in order to get this x by itself in the middle, I have to move the 10. So we're going to subtract 10 to cancel it out. But again, can't just be done in the middle, it has to be done to all 3 sides. So we're going to subtract 10 on the right side and the left side too. So this ends up being a negative 13. X will be by itself in the middle, and then 9 on the right. Again, no division, no dividing negatives, so the signs are going to stay exactly the way they were. Okay, this is a long one, so what I'll do is I don't have enough room to write all the numbers from negative 13 to 9. So what I'll do is I'll just put negative 13 here, I'll put 9 here, just so you get the idea. Maybe I'll put like 0 in the middle or something, it doesn't, but I won't list out every number because I can't fit it all in this number line, so that's okay though. Just make sure the shading is correct and we'll be all right. So at negative 13, we're going to have a closed circle for its sign. And on 9, we're going to have an open circle. And remember, x is between these numbers, so we're going to shade between the negative 13 and the 9. There is our answer, something kind of like that. Now, we haven't done an OR problem yet, but it's not really any different. We're just going to have 2 inequalities at the same time. So let's focus on this inequality first. So to solve this inequality, it's simple. We just have to divide by 3. We end up with x greater than 6. So note, again, I did not divide by a negative, so I did not need to flip the sign. X is simply bigger than 6. The other one, we have 2x is less than negative 4. So same idea. Let's divide by 2. We end up with x is less than negative 2. So yes, there is a negative number here, but there's still no reason to flip the sign because the number I divided by was a positive 2. It's only if you divide by a negative that you have to flip it. It doesn't matter if the answer is negative. It's not like, oh, there's a negative, I have to flip the sign. It's only if you divide by a negative, okay? So this is perfectly fine the way it is. So let's have this all written out. We'll have, let's see, I'll have negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6, 7, and we'll have negative 3. So x is greater than 6. So we have an open circle at 6, and then we're shading greater than. So it's going to be 7, 8, 9, all the numbers that are going to be to the right-hand side. We also have x less than negative 2. So we'll have open circle at negative 2, and the numbers that are less than negative 2 would be negative 3, negative 4, and those. So OR problems will always shade opposite directions. Keep that in mind. You will not be shading in the middle. Whenever you see an OR problem, you will have your shaded regions going opposite ways, and the middle will be blank. Let's do number 18. It's another OR problem. So divide by 6. We'll end up with x greater than or equal to 2. And for the other one, we'll divide by 5, and we'll end up with x less than or equal to negative 3. Again, no flipping of the signs because I didn't divide by a negative anywhere. So let's plot this. So we'll have, let's say negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, negative 4, negative 5 over there. So we're going to have a closed circle at 2, and we're shading bigger than 2. So it's going to be 3, 4, and 5. We're going to have a closed circle at negative 3, and we're shading less than negative 3. So it's going to be negative 4, negative 5. Again, opposite directions, right? No surprise there. There's our final answer. Now we have another AND problem. So you have, again, 3 sides. You have a left side, a middle, and a right. We want to get the middle by itself. We want the x to be by itself in the middle. So in order to try and cancel some of this out, we'll start by getting rid of the 2. We'll subtract 2. Cancel out the 2 first. So we'll subtract 2 from all 3 sides. This ends up being negative 6 less than negative 3x less than or equal to 9. So now I still have to get rid of the negative 3. This is a very important one. This is a negative 3. We need to divide by this negative 3. And you might have heard me just say we are dividing by a negative number, which means we will have to flip our signs. This becomes 2. We're going to flip this sign around. We're going to have x in the middle. We're going to flip this sign around, and this will become negative 3. So if we reverse the whole orientation of this thing, kind of imagine just picking it up and flopping it over, this is the same thing as negative 3 less than or equal to x less than 2. So that's just the same thing but flipped over. So x is between negative 3 and 2. We have a closed circle at negative 3 and an open circle at 2. So we'll have negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, negative 4, negative 5. Again, this will be a closed circle at negative 3, and then an open circle at 2, and we are shading between negative 3 and 2, so in the middle of these circles. And we have, again, our answer. Number 20 is another OR problem, but we are dividing by negative, so make sure you flip your sign. We're going to divide by negative 2, and we're going to have x less than negative 4. We have to flip our sign. Here we're going to divide by negative 1, and again, flip our sign. We divided by negative, so flip the sign. This becomes negative 2. So we're going to have negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, negative 5, negative 6, negative 7. So we're going to have an open circle at negative 4, and we're shading less than negative 4, so it's going to be negative 5, negative 6, negative 7, the left side of that circle. We have an open circle at negative 2, and we're shading greater than negative 2. So we're going to shade negative 1, 0, 1, 2, 3. And again, there's our result. Another OR problem, another problem where we shaded opposite directions. Okay. Now, I really want to practice this for what ends up coming in the next section, part 2 of our review. So we have to be really good at rearranging equations into slope-intercept form and then also graphing them. So that's very key to this. So we're going to start with our first equation, 4x plus 2y equals 10. So we are trying to get y equals mx plus b. Okay, so that means we are trying to get the y by itself. Now, in order to get this y by itself, I have to somehow cancel the 2, and I have to cancel the 4x as well. So those things got to go. Now, the first thing we do is we always move the x term. We're going to always move the x term first. So since it's a positive 4x, we will move it by subtracting 4x. Now, what that does is it cancels the 4x on the left side, so that the left side is just 2y now. But on the right side, I have these two terms. I have a 10 and I have a negative 4x. So we're just going to leave them alone. We're going to leave them there. So I always like to write the x term first, though. So since I have a negative 4x, I'm going to have a negative 4x. I'll write that first. And then I have a 10. It's a positive 10, so I'm going to write plus 10 to indicate that it's positive. So I just have those two terms just listed out over here. You can't combine them, okay? Keep them separate. Because remember, we're looking for mx plus b. So we're getting very, very close to that. However, we still have to get the y by itself. So we divide by this 2. And we'll have to divide everything by 2. Not just one term, but all three of them. So we end up with y equals negative 4 divided by 2 becomes a negative 2x. It's still part of that term. And then 10 divided by 2 is 5. So I just have to graph this line. So this is my m. My m is negative 2. That means my slope is negative 2, which is negative 2 over 1. And my b is 5, meaning my y-intercept is 5. So in order to graph this line that I've just come up with is I'm going to start with my y-intercept, the 5. So I'm going to look at my graph. I'm going to go up to 5 on the y-axis. So starting at the center where 0 is, 5 will be 5 units up. 1, 2, 3, 4, 5. But that puts us right here. So now I use my slope, which is negative 2, also known as negative 2 over 1, to go and trace out the rest of this line. So this means I will go down 2, because it's rise over run. So my rise is negative. So that means if my rise is negative, I'm actually going down rather than up. and I'm going to run 1. So I'm always going to run to the right. So I'm going to go down 2 and right 1. So from my point, I count down 2 squares, and I go right 1 square, and I put a point. And I continue this pattern going down 2 squares and right 1 square time and time again until I can fill out as much of the line as I can. Down 2 and right 1, down 2, right 1, down 2, right 1. Just to fill out the rest of the line, to go leftwards, I'll have to go the opposite thing. So I'll have to go up 2 and then left 1 to kind of continue this pattern. Up 2 and left 1, up 2 and left 1. Now I can see that my line is here, so I'll trace my line throughout, and I've got my final answer. So we're going to try that with 22, 23, 24, or whatever other ones I have here. So negative 2x minus 3y equals 9. Again, our goal is to get the y by itself. So we're going to start by moving the x term. Again, you always move the x term first. So since it's a negative 2x, we'll actually have to add it in this case. So we're going to add 2x. So that cancels the 2x on the left. So on the left side, I just have negative 3y. On the right side, I got these two terms. I've got 9 and I've got 2x. So I'm going to just write the x term first. So since it's a positive 2x, I'll just put 2x. And then since it's a positive 9, I'll put a plus 9. So I still have those two terms, but separated. Now I divide by negative 3. So divide by negative 3 on all parts of this. This gives me y equal to what ends up being 2 over negative 3x, and 9 divided by negative 3 simplifies to just negative 3. So here's my mx plus b. Now, there's a couple ways you can kind of do this. I normally like to think of normally like to just move the negative to the top rather than having it at the bottom. So this is the same thing really as just having y equals negative 2 over 3x minus 3. I like to do that for a particular reason. I like to go down instead of having to go up and left. I'll go down and right. It doesn't really matter, but let's hope that you can still graph this properly. So we have our y-intercept of negative 3. So we're going to start there. We're going to look at our graph, look at 0, 0 in the middle, and on our y-axis, go down to negative 3. So it's going to put us right here. My slope is this number attached to x. In this case, it's a fraction, which is what I want. I really want it to be a fraction because it helps me do rise over run. So I'm going to go down 2 because my rise is negative 2. So this means down 2. And my run is 3. And I'm going to go right because it's a positive 3. So we're going to go from this point. We're going to go down 2 squares and right 3 squares. Puts us here. So we're going to trace that again. Down 2, right 3. Down 2, right 3. And we can start to build our line. We'll go the opposite direction. We'll go up 2 and left 3 just to kind of continue this pattern. Up 2, left 3, up 2, left 3, just to fill it out completely. And there's my line. It should be a straight line. Perfect. All right. Now we have 23. We have 5x equals 11 minus y. All right, let's see here. There's a couple of ways you can do this. What I'm going to do is I'm going to be a little bit clever. I'm going to actually move the y term. A little unconventional, but you can do this. That moves the y term to the other side. So we actually have y plus 5x equals 11. The reason I do that is because then I don't have to divide by a negative because it was a negative y before, and I would have had to divide by negative. I didn't really want to do that. So I just move the y so it'd be a positive y. And now I'll just move the 5x. I'll subtract the 5x. So now I can have the y by itself, and it's positive, which is good. And on the right-hand side, I have 11 and a negative 5x. I've got these two terms. So I'm just going to list them out separately. Since it's a negative 5x, I'll put negative 5x. And since it's positive 11, I'll put plus 11. So I have this equation for my line. You could have gotten the same equation a different way, but this is the way I decided to do it. So our y-intercept is at 11. So this is our y-intercept. We're going to have to go counting up to 11. I don't know if we have enough room for that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 would just be 1 unit slightly higher. So I'll just pretend it's up there. My slope is negative 5, also known as negative 5 over 1. So this means that I'm going to go down 5 as my rise, and right 1. So if I count from that 1 point up there, I'll count 1, 2, 3, 4, 5, and then over 1. That puts us there. And then we'll count down 5 and right 1 again. Down 5, right 1, down 5, right 1, down 5, right 1. And we have our line. Perfect. And we have one more to graph. 6x minus 2y equals 14. So we're going to move the x term, right? We're going to subtract the 6x, move the x term. Leaves us with a negative 2y. Keep in mind that it's still a negative. Remember, these two terms here cannot combine, right? So they keep them separated. We'll have negative 6x written first, because I just like to write the x term first, and then plus 14 because it was a positive 14. We'll divide by negative 2 to cancel out our negative 2. And remember, everything gets divided by negative 2. So we end up having y equal to, now notice this is a negative 6 divided by negative 2, which means it'll be a positive 3x. And then we have 14 divided by negative 2, which means it'll be a negative 7. So here is our slope-intercept equation. Our y-intercept is negative 7, so we're going to start there. We're going to count down to negative 7 on the y-axis. So it's going to be from the middle, we'll go down 1, 2, 3, 4, 5, 6, 7. That puts us here. And then our slope is 3, also known as 3 over 1. So because it's positive, we're actually going to go up in this case and then right 1. So up 3 and then right 1. So from our graph, we'll go up 3 and then right 1. Up 3 squares, right 1 square, up 3, right 1, up 3, right 1. And one more time. And we can see our line, we can trace our line, and we have our answer. Now that wraps up part 1. It was a long video. I feel like I rushed it. I'm sorry if I rushed it, but I just figured you guys, I'm not teaching it again. I'm just trying to give you, reminders as to how to do everything. So that's all of that for the first part. We'll see you in the second part. Remember, good luck on your exam coming up next week.